in Voxxed Days Bucharest, and we've roped in Heinz again this time to talk about the progression through being a
what
soft...
are we going to talk about? Good
Well,
question.
That is a good question.
We're going to wing it a bit.
So we talked about...
From novice to master programmer.
Thank you.
Why
Yes.
not?
So where do you start?
Well, you start with trying to get the stupid program to compile.
Yeah.
And that's how we all start. We start by, why does this line need a semicolon? Why doesn't it need a semicolon?
I think I started with, what's public?
Yeah, what's static? Well, why is,
Yeah.
There's one little puzzle that somebody gave me, which is print hello world without using a semicolon.
How do you do that?
Well, that's the question. You can do it.
Okay. Are you just going to leave that one?
Yes,
okay.
It's a challenge.
I
So
mean, presumably you have
hello
to use
world,
Java.
Got to be Java.
Okay.
It can't be Groovy. It can't be Scala.
Okay.
And your Java program has to compile, run without a semicolon, and print hello world. Right? That's a fun one. But beside that, beside the silly puzzles, I always find that programmers start at the very basic, which is for loop. Now, for loop is something which is completely counterintuitive to normal people.
Yeah.
And if you show a for loop to my mother, she's going to go like, "What is that? You guys on drugs or something?" So we start with that. We start with the while loop. We start with the do while loop. And always amazed when I put up a do while loop on my slides, and people go like, "Why are you using do while?" Well, because it actually fits what I'm doing. I want to do something always at least once, not just never. And so programmers still just fall over that. And Steph and I were talking about this early on, that your lambdas and that actually is at that level, at the most basic level nowadays. Generics is the most basic level. If you want to do any Java programming nowadays, you have to understand generics. You have to understand lambdas. You have to understand streams. Without that, you're lost. You will not understand anything that's going on. So that's no longer like the advanced stuff. That's the beginner stuff. The most basic level is lambdas, for loops, variables, fields. What is a local variable? What is a parameter? All of that stuff. That's the most basic stuff.
I think I'm still at that level.
Well, we all are at that level at some point. Right? And then above that, we go to data structures and algorithms. And those are very important. That's some stuff that you'll learn if you're going to a bit more formal computer science education. You'll learn about, what is logarithmic complexity, what is linear complexity. I was looking at the Apple language, Swift. It's a new language. And what's quite interesting is that in their data structures, they have, for every data structure, they tell you what the complexity is of all the different functions. So they'll say accessing here is order n, or sorting this is order n times log n, or whatever it is, or searching is log n, whatever it is. So it's not as basic as I'm trying to get my code to compile, but it is still fairly basic. It's still fairly basic. It's still, you're getting a lot of wins out of having a good algorithm. Far more wins than trying to parallelize or trying to, come up with reactive systems, anything like that. Your algorithm is going to be more powerful than anything. Get a good one, and you're going to have fun, enjoy. Bad one, it's going to take forever.
Yeah.
And we talked about this fork join thing before, and the first algorithm I had would have taken 10 to the 200 years to complete.
Yep.
That's a very, very long time.
But we haven't tested that.
Well, in theory, it will take that long. Might take longer or shorter, but we'll never know. And if you wanted to parallelize it, you would maybe get it 4 times faster, or 5 or 10 times, or 16 times faster, depending on the cores you've got. But you're never going to get it that much faster, from 10 to the 200 years down to 40 seconds. It's not going to happen with parallelism. So your algorithm is always where you start. And then above that, there's another level. Once you've mastered algorithms and data structures, is where you look at the design of the application, the long-term impact of your application. What's the cost going to be of the technical debt that you put into the system, and how can you change it in the future? How can you reuse parts of it? Building for extensibility. And you can get yourself horribly wrong with that because it's very hard to predict the future, and so people tend to sometimes over-engineer. And I'm partially German, so Germans are very good at over-engineering stuff. As you know, if you take any German product, it's like completely over-engineered. And in software, we tend to do the same. Because I'm also partially German, that sometimes we over-engineer stuff, we over-design it.
So it's interesting. I kind of think actually you've seen the film Interstellar?
Yeah.
You know, at the end where he's suspended in space in the multi-dimensional library, and the books are cutting through time and space. It does feel like there's a kind of something through time and space that cuts through those levels, because I know at various points I've looked at, I mean, I definitely look at the how to compile on a regular basis, but I've definitely looked at all of those levels, whereas if I had to categorize myself, I'd put myself right down at the bottom.
I'm sure that's not quite true. I think you're not giving yourself enough credit there.
It was constantly
Because
relearning.
when I say linear, you probably do have some idea of what I'm talking about.
Like linear regression? Or...
No, like if I'm searching for an item in a list, if I want to make sure that the item is not there, I've got to go through the whole list to make sure it's linear. Versus a tree, it's a binary search.
Yeah.
So you've heard about this.
Yeah.
So you're not right at the bottom. I mean, come on, give yourself some credit.
Oh, okay. But I don't feel like those levels are segregated. I feel like maybe you can swap in and out of the levels.
Yeah. You need to. So what I found is that a lot of programmers, they stay mostly in the lower levels, where they're just happy when their program compiles and they can go home.
Yeah.
They don't take the time to think, how could I do this better? How could I do this with less code? Most of the time, when I add functionality to existing code, I end up with less code at the end. So I've added functionality, and I've reduced the code base. As opposed to what most people do is they copy and paste the code and change a few variables, and then they end up having more code. And the problem with having more code is there's more code to maintain afterwards.
Yeah. It's one of the best things I learned, actually, right at the beginning of my career. I had a really good mentor. He said, the best code is the code that you don't write.
Yeah.
Never write any more code than you absolutely have to.
Absolutely.
And that's actually quite a nice lesson where you think, oh, I can relax.
No. I don't get impressed with people who write 2,000 lines of code per day. That's so what? I normally write negative numbers. So that's, in my opinion, is the way to do it. And if I can reduce the code base substantially, that's, to me, much better than having, thousands of lines which somebody has to maintain. I spoke about this in Thessalonica at another event, and I looked at different characterizations of people, and some people are lazy in a good way, and others are lazy in a bad way. There are three characteristics of a good programmer. One is laziness, the other one is impatience, and the third one is hubris.
That's an interesting one.
Not my idea. This is from some famous guy that I can't remember now. But those three. And laziness is a characteristic that you need as a programmer. Because you need to think, how can I save myself work in the future? How can I avoid having to do this over and over again?
Yeah.
Super. And so the one lazy programmer will go and copy and paste all the code, just change a few variables. But that's lazy in a bad way. That's a really bad lazy, because it means all the bugs that you've produced are now duplicated over and over and over again.
Yeah.
So if you need to fix a bug, you've got to fix it in 10 different places.
You've got multiple points of failure.
Yes. And the same bug is repeated. You copy and paste, you're repeating the bug too. And the second type of programmer who's not lazy enough is the one who goes and types everything over and over again, reinvents the wheel every single time. That is also going to cause problems, because you're going to waste a lot of programming effort in doing unnecessary work which has been done before.
And what's the third type of laziness?
The good laziness.
All right.
Where you're constantly looking at and going, I've done this now twice, and I'll do it a third time, but before I do it the third time, is there a quick way that I can optimize it so I don't have to do it a fourth time? And it's a constant it's a constant way of thinking. It's not something which you take off when you stop programming. It's a life way of thinking. It's how you think as a person. It's how can I avoid having to do this job over and over again.
So how do people advance from the first or second stage?
Right. First and second stage, there are a whole bunch of good books you can read on data structures and algorithms and things like that. There's, of course, the classical art of computer programming, which I don't want to recommend because it is incredibly hard to read.
Okay.
But interestingly, it's referenced quite a few times in the JDK.
Oh, right.
For example, if you want to see how does thread local work, right?
Do you think it's worth reading even because it's difficult then?
It's something which you should do at least once as a programmer.
Okay.
I read it once when I was at university, and I bought a copy. It's like this thick, like three or four volumes. It's on my tablet at home. I probably will never read it, but it's there in case I ever have nothing else to do. I'll read it again. But it's interesting because there are, as I said, thread local. It's like a class which you might never think about, but actually inside there is a special hash table, and they're using the golden ratio, which you'll find inside Art of Computer Programming.
Oh, right. Okay.
For the way they do the distribution inside the hash table.
So for people who don't know, the golden ratio is most commonly found in classical art.
Right.
It's the
perspective. It's somehow related to that.
Yeah.
I can't remember the exact details, but it's like it's some calculation number to make sure that the numbers are well distributed.
That's interesting. So after the art of computer programming, what's next?
The next one you have to read is the Gang of Four Design Patterns book. Now, I've got a stack of books like this on design patterns at home. Yeah. And they're not bad, but the one that you have to read as a programmer is Erich Gamma et al. Gang of Four Design Patterns. Even it's got C++ and Smalltalk in it, so it's not even Java.
Yeah.
But it's like 20 years old, so it's not even a new book. But that's like the foundation of all the other books that have been written about that. So if you don't read that book, the other books will not necessarily make sense. Plus, a lot of other books don't have necessarily very good explanations of what's going on. So that one you have to read as a programmer. Other books which I found very useful is like The Pragmatic Programmer.
Yeah.
That's very good. And then design. A book which I like a lot is Head First Design Patterns.
I like the Head First series.
It's great.
Yeah.
They're great.
I've got Head First Java as well, I think. I like it's very accessible.
You know, there's an interesting discussion on the Java Champion mailing list at the moment about what tools authors use to write books. And most of the guys are like, I just use LaTeX, VI, Emacs, LaTeX.
Yeah.
And one of the Head First authors said, the problem with doing that, you make your life easy as a writer, as an author, but you're pushing the effort, the cognitive effort onto the reader.
Yeah.
And I think that's very true. I think what's happening is that most books you pick up, and they all look the same. The technical books all look the same. They look like a university thesis, because that's really what they are.
Yeah,
and the Head First is different. It's like all over the show, and you can't do that very easily with LaTeX. You need a different tool for that. The problem is that it's very hard to find tools like that because there's no market in those tools. Somebody's got to build those tools, like Adobe used to make those tools. But somebody has to make those tools, but those tools are not very popular because people don't want to pay money to write books because there's no money in writing books.
Yeah.
So why would you pay for a tool? And without the tool, the book's going to look terrible, so people won't buy it, and it's a vicious circle. So that's the problem with it. So Head First Design Pattern is a great book. And then the next level, of course, is concurrency and reactive systems. Those two together. And there are a bunch of books for that as well.
As well as your newsletter series.
Yeah, I've got hundreds of articles I've written about Java specialists.eu.
Oh.
And tutorials and a bunch of stuff.
Well, we'll have to talk again when I've read all of the books.
So 2025, is that good for you?
Yeah, I mean, I'm not sure where I'll be, but I'm sure I can make some time. Oh, thank you very much.
Voxxed Moon or something.
Yeah, possibly. Well, I wouldn't say no to space travel. See whether or not Stefan's got it in the budget. Oh, thank you very much, Heinz.
Thank you.